All right, so today we're going to talk about how spread out the blob is and how do we measure its spread. So these are called measures of dispersion. A measure of dispersion is any of several measures designed to reflect the amount of variability in the set of scores. In other words, how spread out it is or how tightly compressed it is. Common measures of dispersion: range, mean absolute deviation, median absolute deviation, standard deviation, and variance. Now, like I mentioned last time, we had all those measures of central tendency. The mean is really the only one that's going to stick with us beyond section 1. I mean, we'll talk about the other ones a little bit, but we're going to be using the mean a lot. From these, the only ones that are going to stick with us for the whole semester are standard deviation and variance, which are very closely related. This is this squared, and this is the square root of this. So if you know one, you know the other, and we'll talk about that in a bit. But the rest of these we're only going to be using primarily in this section. All right, so the first one is the range. The range is simply the difference between the highest and the lowest. So, remember we had the mid-range and I said that it's not really that good because it's affected by extreme scores? So if we had professional golfers and then Tiger Woods was over at that wall, the mid-range would be halfway between here and that wall, which is not a good indication of the center of the data because the center is pretty much right here. The range is going to tell us how spread out this is. I would say, if this is the professional golfers thing again, that this is how big my blob is, and that's just some crazy point off in Never Never Land. However, if we actually calculate the range, we take the highest, which is the wall where Tiger is, and subtract the lowest, so the range would be from here all the way to the wall. Which, is it? No, because all of the scores are right here except for one. So I would say that the spread of the data is pretty much here. So sometimes the range can be useful as long as we don't have any super extreme values. So we just take the highest and subtract the lowest. So the procedure: arrange all scores from smallest to largest. You don't even really have to do that as long as you can identify the smallest and largest number. Subtract the lowest score, the minimum score, from the highest score, the maximum score. Can't get any easier than that. So below are measurements gathered from 10 Red Fox tracks. So this is my smallest for my front foot length. This is my largest for my front foot length. So I subtract that from this. So 2.4 minus 2.2 is 0.2. This is how spread out that data is. The range is, the range of the width is this and this, smallest and largest. We take the smallest away from the largest, which is 2.05 minus 1.95, and we get 0.1. So this is our range. Now below here, we have a little illustration of the range and the mid-range. So if this is my smallest value, and this is my largest value, the mid-range is halfway between the two of them. And my range is the distance from here to here. So because of that relationship, if we know, for example, this and the mid-range, we can figure out what this is, right? Because the distance from here to here is the same as the distance from here to here. If we know what, say, this is and the range, then we know what this is and this is also. So you can kind of use them back and forth to figure out the maximum, minimum range, and mid-range with this relationship between the two of them. All right, any questions on the range? Fairly straightforward. All right. We talked about this a little bit already, but let's go over it once more. So we have an opening on the U.S. Olympic team's archery team. And they have 2 people competing to be on the team. So they set up 2 targets with the bullseye in the middle, and the first person shoots like this, and the second person shoots like that. Which person do we put on our team? This person had bullseyes, but had arrows that missed. This person had no bullseyes at all. Which one? This one? This one. Okay, this one. And why is it? Because in sports, most of the time, it's easier to fix the center than it is to fix the spread. So this person, if we can figure out how to move the center of his blob or her blob from here to here, all those would be bullseyes. And that might not be that difficult. It could simply be an equipment issue. Right? It could be the balance between the bow and the arrow. Arrows are rated, they have a spine, which is measured by, they put the arrow on pegs and they pull down the center to see how hard it is to bend the arrow. You have to shoot an arrow that is correctly spined for a bow. If you don't, it won't fly through the air correctly. So this is my arrow. Actually, let's do this. If this is my arrow, if I shoot an arrow that has too strong of a spine for the bow, in other words, the bow is weak for the arrow is going to do this. It's going to stay perfectly straight. It's going to flop through the air. If, however, the bow is too strong for the arrow, then the arrow is going to do this. It's going to bend in the middle, but substantially as it oscillates and goes through the air, which will make it not accurate. If they're correctly balanced, the arrow will bend in the center slightly, and it will fly perfectly straight through the air. So it could be just an equipment issue. If this were not on the Olympic level and we were dealing with like regional competitors or even local competitors, this is probably caused by hand-eye imbalance. For example, everyone knows if they're right or left-handed, but a lot of you probably don't know which is your dominant eye. Everyone has an eye that they look through primarily. And if it's not the same, for example, if you're right-handed and your left eye is your dominant eye, which is the problem I have, then in sports that require you to aim, you're going to probably be off. For example, when I shoot pool right-handed. So the pool cue is like this, right? And what do? What eye is right over the top of the pool cue? Your right eye. Problem is, I look out of my left eye. So because of that, I have two options. I either have to close my right eye and kind of move my left eye over like, I'm sorry, I have to close my left eye so I'm looking only out of my right eye, or I have to actually move my left eye over the pool cue. And that goes for archers too. If the arrow is resting right here and they're looking down the arrow shaft and their left eye is dominant, they're not looking directly down the shaft. So it could be just an eye and hand imbalance. Don't do this now, you'll all look goofy, but the way you tell is you pick an object on like the clock on a distant wall. You have to keep your arm perfectly straight, and then you put the circle around the object. And then you bring it back so you can continue to see it, and whatever eye it's over, that's your dominant eye. Most people's eye dominance and hand dominance match. It is not that common to have them switch, but it is possible. All right. So the mean absolute deviation. What this is going to do for us is this. So remember the bullseye that had the target that had some bullseyes and the rest of the arrows were out. If I assume the center of the bullseye was my mean, my average arrow, and I went through and I measured the distance from the center out to every arrow. So let's say this was 10 inches, this was 5 inches, this was 2 inches, this was 1 inch, this one was 5 inches, and added all those distances up, and then divided by the total number of distances, that would give me the average distance an arrow is going to be away from that bullseye. And that is what the mean absolute deviation, or MAD, will do for us. The mean absolute deviation is the absolute average amount by which scores deviate from the mean. Now the reason we use absolute is because some are going to be below in negative distance, some are going to be positive distances. We don't care about negative and positive. We just want to know the average distance away, regardless if it's positive or negative.